find significantly easier. Okay, but now you must pay attention to details. What is the difference in those two parts of that equation? Double angle, single angle. Excuse me, Justice, you're not even looking this way. I know JC is appealing, but
That's my cousin. That's gonna be our recording forever. Restart out.
do I need to restart it?
No.
All right, so yes, you got single angle, double angle. You can't solve these with different angles. You have to get everything changed to the same kind of angle. How are you going to change it to the same angle? The fact that none of you are sitting there, or almost none of you are sitting there with taking a single note, I got about 2 or 3 of you, it's concerning because you all showed up today making silly mistakes with your calculators and not trying to solve those by calculator, the ones that you were supposed to be doing inverse sine. We did several of those last class and you don't have a clue about that. Makes me wonder how well you're learning. So if you're not going to take notes, then you better be quiet and listening because I'm tired of talking over you. And realize you don't want me angry because I can make this quest nice or I can make this quest mean. So, yeah, it's a double angle, and I didn't hear anybody tell me how can I get them all changed to the same angle. Probably because I couldn't hear. You use a double angle identity, so therefore you're going to have what in front of you? The yellow sheet's going to need to be in front of you. Now, is this one of the double angles, is this one that had 3 different choices, or is there only one choice?
There's only one choice.
For this one, there's only one choice. So you like it when you get sines, but when you get a cosine double angle in a problem, how are you going to know which one to pick?
Pick one that crosses off.
Crosses off, or like if this had been cosine double angle, you would notice, well, I've got a sine over here. You want to get the whole thing in all signs, so if you have other signs in the problem, pick the cosine double angle that has all signs. If your problem has lots of cosines in it, pick the one that's got all cosines in it. So if you look at the rest of your problem, it usually tells you which one to put in. But in this case, we don't have to worry about it. We know sine double angle is 2 sine x cosine x. Okay, so now I have 2 different trig functions in it. What do I do? Yeah, this is just a common factor. No big deal. I can take it out. Okay, what is left when I take the sign out? 1, thank you. Okay, can you solve these? Yeah, they're nice and normal. Yes, and can we solve this one in our head? Positive a half. Because you would subtract 1 and then divide by -2, so you'd actually end up with a positive half. Yeah. Okay, so then we are solving this one in radians, so that kind of was a big hint. You're going to have to come out with special angle values. All right, we just talked about this. Will there be 1 or 2 answers when sine equals 0? 2 answers. On your special angles, where does sine equal 0?
5 or 2. No, that was
0.
It equals 0 at 0, and so therefore we're in radians, so not 180, but pi. So 0 and pi are 2 of your answers. A half, we've got to actually figure out what quadrant we're in. So what quadrant are we in if we're positive 1/2? 1 and 4. And cosine equals a half at radians. 5 or 3. The most missed one on the flashcard test. Always, where cosine equals a half. So what are my answers? Okay. Yeah. 5 or 3 and 5 pi over 3. Did I do anything to cause me to have to check my answers?
No.
No. What are now the 2 things that make you check your answers? Fractions and squaring both sides. And we did neither of those, so we're good. We have lovely answers. Okay. All right. So that wasn't so bad, but you have to read your angles. So we'll see if you notice what's different in this problem. What is or what bugs you about that problem, I should say. This one is degrees.
Yeah, there's a sin and a cosine.
It is, there's a sine and a cosine, but the bigger problem is there's a single angle and a half angle. You want to get the angles worried about first, then sweat whether you have to do something with your function. So, what am I going to do about a cosine half angle? Yeah, it's that horrible identity with the square root.
How come you never got your eyes? She did, it just fell off.
It just doesn't show up half the time when I do it. Just this. I really do got the most time, but it doesn't catch it unless I slow down, and I don't want to slow down. Okay, so now I have this gigantic mess. I have a square root in my problem.
How do you know if it's plus or minus?
Well, it's not going to matter this second because we're going to do what Abby just said. We don't want that square root in our way, so what are we going to do with it? We're going to square both sides. So yes, we're going to get to check our answers when we get done. Hot dog. So if I square both sides, that means I know it will become positive then. So I'm going to have sine squared equals 1 plus cosine of x over 2. Okay, now you have two problems.
Sine squared. Sine squared.
Okay. I have a fraction, which I don't want, but I also have two different trig functions. I got a sine and I got a cosine.
Multiply the 2 over the sine.
Okay, I'm hearing multiply the 2 over. Okay, you're actually going to do both of these things. It doesn't matter which order you do it in. So, yep, I'd end up with 2 sine squared equals 1 plus cosine. But still I have two different, I have sine and cosine in the same problem. And I've got a 1, so they're not going to...
1 minus cosine 2.
Okay, using fundamental number 6, yes, I could change sine squared into 1 minus cosine squared. How should I write this, I guess I should say properly? With parentheses, because the 2 has to distribute. And now, it's not that big a deal from here. We've got it all in cosines. It's just a normal solve when we clean it up. It's going to be quadratic. It's got a cosine squared. So I would go to the right so that I get it all positive. Now, is it going to become a 3 cosine? No, because that's cosine squared. That's going to go over. I'm going to have a plain plus cosine of x. And then when I subtract 2, minus 1. Okay, what do you think? Factor or formula? Yeah, this looks very factorable. 2's and 1's, get a 1 in the middle, shouldn't be a problem. So we know it's 2 cosine and cosine, and 1 and 1. Okay, I heard both ways. Minus plus. Because we want outside to be positive 2 cosine, so we get the positive in the middle. And are these tough to solve? No. So cosine is going to equal a half, and cosine is going to equal -1. And even though we're doing this one in degrees, even though we really could do it in radians, those are special angles, so we're happy. But since we're in degrees, 30. Not 30. 60, since it said solve in degrees, and we'd be 60 and 300. That's not bad. And then cosine equals -1. If it's a 1, it's on the quadrant line. It's +1 at 0. So it's going to be -1 over here, yes, at 180. And you have 3 lovely answers. Are we done? Yeah, we squared both sides. We have to check them. This one isn't bad to check, because if you go clear back to the original problem, it was sine of x equals cosine of a half angle. It's pretty easy checking. It was 6,380. So if you put 60 in there, you're just asking yourself, does the sine of 60 equal the cosine of what? 30, because you're going to divide the angle by 2.
Yeah.
Yeah, I don't.
Sine of 60 is square root of 3 over 2. Cosine of 30 is square root of 3 over 2. You can put it in the calculator and check it too, but yeah, that works. So then same thing, does sine of 300 equal cosine of half that, which is 150? Well, 300 would be a 60, so that'd be square root of 3 over 2 again. But we're in the fourth quadrant, so it would be negative. 150 would be a 30 in the second quadrant, and it would be negative, so it would be square root of 3 over 2. That one checks. Hot dog, we're 2 for 2. Yeah, amazing. This is actually a fairly freaky problem, because they do all check. Cosine of 90 is 0. Sine of 180 is the same thing as sine of 0. It's 0.
I have a question.
So they check.
So you have cosine of negative 1 back there, and cosine of 1 is 0.
Cosine of positive 1 is 0. It's positive 1 on this side of the axis, which means it will be negative 1 on the negative side of the axis, which is 180.
I thought, like on that over there, the cosine of 0.
Actually, I was doing cosine equals negative 1.
Okay, so that's the same thing.
Yeah. Oh, cosine equals 0, is that the one you're talking about?
Yeah.
Because see, 0, it doesn't matter whether you're on the positive or negative side, because 0 isn't positive or negative. That's why with 0 you get 2 answers. But when you're doing a 1 with a negative, you can only be on one side of the axis, you only get one answer. Perfect, good. Alright. So, that was fun, huh? I got one more for you. Maybe two, depending on whether you think you've got this or not. This is your special case problem. It's actually quite easy to solve, but it is my most missed problem. We just don't see it coming. And then people go to elaborate lengths to solve this by a harder method. So, it's not hard at all if you notice what's happening. Oh, it's a triple angle. How about that? And we're solving from 0 to 360. So, okay, do we have identities for triple angles? No, we don't have identities for triple angles. Okay. But, you'll notice here, every single angle in the whole problem is a triple angle. They're all 3 thetas, and you'll notice also the entire problem is cosine. So you don't have to use an identity to do it. But there has to be 2 conditions for this. It has to all be the same multiple angle. So all 3 thetas, all half thetas, all the same angle. Oh, that should be must be. Try that again. They all have to be the same multiple angle, and it has to all have the exact same trig function. In this case, it's all cosines. If it is, you can just proceed to solve it like normal. Just ignore the 3 theta for a while. We'll deal with the 3 theta when we get down to the very end and get our answers as angles. But otherwise, you can just work it like a usual problem. But I need to stop this now, because I won't get into this problem.